Okay, let's kick things off with an introduction to cloud computing. Basically, instead of needing your own servers and all the headaches that come with them like maintenance, updates, and scaling, you're renting those resources from a provider like Amazon Web Services, Microsoft Azure, or Google Cloud. It's a really powerful shift. The main benefits are things like being able to quickly scale up when needed, saving money because you only pay for what you use, and knowing that your services are reliable and available. There are three main service models: infrastructure as a service, platform as a service, and software as a service, each offering different levels of control and management. Okay, let's talk about how cloud services are structured. There's really three main ways to access them: IaaS, PaaS, and SaaS. IaaS is like renting the individual parts of a computer. You get servers and storage, but you build everything else on top. PaaS takes it a step further. It gives you a whole platform for building your apps without managing the underlying infrastructure. And finally, SaaS lets just ready-to-use software that you access over the internet, like Gmail or Salesforce, no management needed. Let's talk about where you can deploy your cloud applications. There are four main models to consider. First up is the public cloud. Think AWS, Azure, or Google Cloud. It's like renting a massive server farm. It's incredibly scalable and often very cost-effective, especially if your demand fluctuates. Next, we have private clouds, which are built and managed by you, either in your own data center or hosted somewhere else. This gives you more control over security but comes with higher costs and the responsibility of managing everything yourself. Hybrid cloud combines these two, using public for some things and private for others, allowing you to balance cost, security, and flexibility. Finally, there's community cloud, where infrastructure is shared among a specific group with similar needs. It's a good option if you can find one that fits your industry or organization. Okay, so let's talk about cloud computing. It's really revolutionized how businesses operate. On one hand, the benefits are huge. You can dramatically reduce costs because you only pay for what you use, and scaling up or down resources is incredibly easy when demand changes. It also means faster development cycles and a lot more flexibility in deploying new apps. But it's not all sunshine and rainbows. There are challenges to consider. Security concerns are top of mind, so careful planning is essential. Vendor lock-in can be tricky too, and managing complex cloud environments requires expertise. And let's face it, you need a reliable internet connection to really make the most of everything. Let's take a quick look at the big players in cloud computing: Oz, Azure, and GCP. Amazon Web Services is the most established, offering a truly massive range of services from virtual machines to storage and databases. Microsoft Azure has deep ties with Windows Server and other Microsoft products, making it a great choice for organizations already invested in that ecosystem. And Google Cloud Platform shines when it comes to data analytics, machine learning, and container orchestration, thanks to its strength with Kubernetes. Okay, let's talk about virtualization. It's a really important concept for any aspiring cloud engineer. Basically, it lets you run multiple operating systems and applications on just one physical computer. Imagine having several separate computers all running on the same hardware. There are different types of virtualization, including hardware virtualization, which mimics actual hardware, software virtualization using hypervisors like VMware or Hyper-V, and containerization, a lighter approach that isolates individual apps. Okay, let's talk about hypervisors. They're like the operating systems for your virtual machines. We have two main types, Type 1 and Type 2. Type 1, often called bare metal, is installed directly onto the computer hardware itself, giving it a really direct connection to everything. Think of it as the most efficient option. It's used in large companies where performance is key. On the other hand, Type 2 hypervisors run asterisk on top asterisk of an existing operating system like Windows or Mac. VirtualBox and VMware Workstation are good examples. They are easier to set up, but don't quite have the same level of efficiency as a Type 1. Okay, so let's talk about compute services, basically how we actually run our applications in the cloud. Think of them as virtual servers. We have three major players here: Amazon EC2, Azure Virtual Machines, and Google Compute Engine. They are all very similar in concept, providing you with a virtual server to host your code and data. EC2 is Amazon's offering, Azure VM are Microsoft's, and GC is Google's. Each has its own strengths. It really comes down to what you're most familiar with and what best fits your overall cloud strategy. Don't get bogged down in the details just yet, but understanding these three core options is a great first step. Okay, let's talk about storage. It's absolutely critical when you're building cloud applications. We have three major players in the game: Amazon S3, Azure Blob Storage, and Google Cloud Storage. They all offer object storage, which is great for storing files like images, videos, or backups. S3 from AWS is a really mature service with tons of features like versioning, so you can always go back to an older version of a file if needed. Azure Blob Storage works brilliantly within the Microsoft ecosystem, and Google Cloud Storage offers global availability at competitive prices. When it comes to choosing the right one, think about where your other cloud services are located, what's going to work best for your budget, and any specific needs you have around security or location. Okay, let's talk about cloud storage. There are three main types, each with its strengths. First up is block storage. It's like a regular hard drive you attach to your virtual machine, offering really fast access for things like databases and operating systems. It can be more costly because it's always on. Then we have object storage, which stores data as objects in buckets. Think of it like massive digital filing cabinets, perfect for images, videos, and backups. It's incredibly scalable and generally the cheapest option when you don't need constant access to your data. Finally, there's file storage, which lets you mount cloud storage just like a local drive on your computer, great for sharing files and collaborating with others. Let's dive into cloud networking. It's super important for anything you build in the cloud. Basically, a VPC is like your own private network inside the provider's infrastructure, giving you control over how things connect. Then you break that down into subnets to organize everything, and route tables decide where traffic goes. Finally, security groups and network ACL act as firewalls, making sure only the right people can access the right resources. Okay, let's talk about virtual private clouds, or VPCs. Basically, a VPC is like creating your own private network inside the Amazon Web Services cloud. It gives you a level of isolation and control that's really important for security and managing your resources. You get to decide everything from the IP addresses used by your servers all the way down to how traffic flows through your network. It's also great if you need to connect your AWS environment with your existing on-premises data center, which we can do using technologies like VPN or Direct Connect. Okay, let's talk about the building blocks of your cloud network. We're focusing on subnets, route tables, and internet gateways. They're all essential for connecting your resources effectively. Subnets are like dividing up a large IP address range into smaller, more manageable sections, making it easier to organize and secure things. Next, we have route tables. Think of them as the instructions that tell your cloud instances where to send data. Each subnet can even have its own set of routing rules. Finally, an internet gateway is what allows your private network, your VPC, to talk to the outside world, like the internet. It's your bridge to everything beyond. Okay, let's talk about how we keep our cloud resources safe. We'll focus on security groups and network ACL. They're like digital firewalls for your servers. Security groups are a bit easier to manage. They sit right on individual instances and control what traffic can get in or out based on ports and protocols, kind of like a personal firewall. Think SSH and HTTP. They automatically take care of the return trip too. Then we have network ACL. These operate at the subnet level, acting as a bigger firewall for an entire section of your network. They are stateless, so you need to specifically allow both incoming ** and * outgoing traffic, which gives you more precise control. Let's talk about load balancing. It's a really crucial part of building robust cloud applications. Essentially, a load balancer acts as a traffic director, spreading incoming requests evenly across multiple servers. This prevents any single server from getting overwhelmed and keeps your application running smoothly for everyone. We've got three main players here: Oz's L, Azure Load Balancer, and Google Cloud Platform's load balancing options. Each has its strengths, so understanding their differences is key to making the right choice for your specific needs. It's not just about distributing traffic, it also improves availability and responsiveness, a win-win for users and developers alike. Okay, let's talk about Cloud DNS. Basically, it's how we manage your domain name, like example, Common Cloud. Instead of relying on a single server, which can cause delays and problems, Cloud DNS uses a whole network of servers spread out across the globe. This means faster website loading times for visitors no matter where they are, and it's also much more reliable because if one server goes down, another automatically steps in. It's especially great when you're using other cloud services like load balancers or CDN to make your site even better. Let's talk about keeping your cloud infrastructure running smoothly. Auto-scaling groups are like a self-managing team for your EC2 instance, as they automatically add or remove servers based on demand. They do this using scaling policies, which are basically rules that tell them when to make adjustments. You can set a target for things like CPU usage, schedule scaling events, or define specific steps to increase or decrease capacity as needed. It's all about balancing performance and cost. Okay, let's talk about Elastic IP and how they fit into the bigger picture of your cloud infrastructure. Basically, an Elastic IP is like a fixed phone number for your resources. You can move it around easily. This is really helpful when scaling your applications or managing security groups, because you don't need to update multiple rules every time you change where something is hosted. Now, we also have private and public IP. Private IP are only accessible within your network, while public IP go out into the internet. Elastic IP function as dynamic public addresses, making them perfect for things like load balancers or bastion hosts. Okay, let's talk about IAM. It's a super important part of being a cloud engineer. Basically, it's how we control access to everything in the cloud. Think of it as digital lock and key management. You need to establish who is trying to get an identity, what they are allowed to do with those resources, access control, verify that person's identity authentication, and then make sure they only can do things they are authorized to do. Authorization. Managing these components effectively is critical for protecting your data. Okay, let's talk about IAM, identity and access management. It's absolutely vital for keeping your cloud resources safe. At the heart of IAM are policies and roles. A policy is essentially a permission list. It outlines exactly what users or services can do within the cloud. We can see an example here in YAML format, showing access to S3 objects and buckets. Now, roles are like temporary identities. They are containers for those permissions. They are incredibly useful when things like EC2 instances or Lambda functions need access, because you don't have to manage individual credentials directly. It all simplifies the process significantly. The key thing to remember is that policies grant access, and roles provide the identity with that access. Let's talk about Key Management Services, or KMS. Think of it as your central hub for all things encryption keys in the cloud. KMS is a fully managed service by AWS, meaning you don't have to worry about setting up and maintaining complex hardware security modules yourself. It makes it really easy to generate, store securely, rotate regularly, and ultimately use these keys across different parts of your AWS environment, like your storage buckets or databases. The main benefit? Increased security and simplified key management, which is super helpful for meeting all those regulatory requirements you might be dealing with. Okay, let's talk about multi-factor authentication, or MFA, and how it's a critical piece of cloud security. Basically, MFA goes beyond just your password. It's like adding another lock to your account door. Think of it as requiring 2 or more things to prove you are who you say you are. This dramatically reduces the chances of someone gaining access if they somehow manage to steal your password. We'll cover some common methods, like using authenticator apps on your phone which generate a code that changes regularly, and hardware security keys, which are super secure physical devices. SMS is an option, but generally considered less safe than other choices. Let's talk about monitoring and logging. These are absolutely vital for keeping your cloud infrastructure running smoothly. We're going to cover three main players: Amazon CloudWatch, Azure Monitor, and Google Cloud Operations. CloudWatch is fantastic for visualizing metrics within the AWS world, while Azure Monitor is deeply integrated with everything happening in Azure. And Google Cloud Operations, now known as Stackdriver, offers a really powerful solution when you're working with distributed applications across GCP. Let's talk about keeping your cloud applications running smoothly and protected from the unexpected. High availability, or HAW, is all about minimizing downtime. It's like having a backup system ready to go if something fails. Think of it as redundancy, where multiple components work together so that one failure doesn't bring everything down. Then we have disaster recovery, which goes a step further. It's the plan for when something really big happens, like a major outage in an entire region. We'll look at some common techniques for HA, like load balancing and auto-scaling, and then dive into different DR strategies, from simple backups to more sophisticated approaches like pilot-light recovery. Okay, let's talk about backups and restores in the cloud. These are absolutely essential for any serious operation. Basically, they're how you get back up if something goes wrong. We'll look at a few key strategies. First, regular snapshots allow you to create copies of your infrastructure at specific points in time. Next, backup as a service providers can automate this process and keep your data offsite. And finally, immutable storage is a really powerful technique. It prevents accidental changes or even ransomware attacks from damaging your data. Okay, let's talk about cloud storage classes. They're super important for managing your data effectively and keeping costs down. Think of it like this: not all data needs to be instantly available. Amazon S3 offers different tiers designed for varying access patterns. You've got standard storage, which is great for things you need to access frequently, like a website or an application. Then there's infrequent access, perfect for backups and disaster recovery scenarios where you don't need immediate access but still want relatively quick retrieval times. Glacier and Archive are really designed for long-term storage of data that you might only need once in a blue moon, and they're incredibly cost-effective. The key is to understand how often you'll actually need to pull your data, and then select the class that fits those needs best. Okay, let's talk about Content Delivery Networks, or CDN. Think of them as a global network of servers designed to speed up content delivery for your website and applications. Basically, instead of everyone requesting the same data from one central server, which can take time and slow things down, a CDN stores copies of that content on servers closer to where users are located. This dramatically reduces latency, making everything load faster. We've got three major players here: AWS CloudFront, Microsoft Azure CDN, and Google Cloud CDN, all offering similar core functionality but with different strengths and integrations within their respective cloud platforms. They're essential tools for any cloud engineer looking to optimize performance and reliability. Okay, let's talk about cloud databases. As a cloud engineer, it's important to know your options. We've got a fantastic range of managed database services on GCP. First up is Amazon RDS. This is like the familiar SQL world, offering MySQL, PostgreSQL, and more with a standard relational database interface. Next, DynamoDB is a NoSQL powerhouse, super scalable for things like game scores or user sessions. Azure Cosmos DB offers global distribution and supports various data models. Bigtable is great for massive analytical workloads, while CloudSQL provides a managed version of traditional databases that you might already know. Okay, let's talk about managed NoSQL databases. These are a huge shift in how we handle data in the cloud. Basically, they're like relational databases but with much more flexibility and scalability, great for handling all sorts of different kinds of information. Some really popular choices include Amazon DynamoDB, Azure Cosmos DB, and Google Cloud Firestore. The best part: the cloud provider takes care of all the heavy lifting around managing these services, meaning less time worrying about backups, updates, or scaling your database as it grows. You just pay for what you use. Let's talk about serverless computing. Basically, it's a way of running code in the cloud without having to worry about managing servers yourself. That's a huge win for operational overhead. It scales automatically as needed, and you only pay for what you use, which can be incredibly cost-effective. We've got three major players here: AWS Lambda, Azure Functions, and Google Cloud Functions. Each has its strengths. Lambda is super mature and integrates well with the whole Amazon ecosystem. Azure Functions plays nicely with Microsoft services, and Google Cloud Functions is known for being easy to get started with. Let's talk about event-driven architectures. Imagine a system where parts don't constantly check in with each other to see if something has changed. Instead, they react when something does change. That's the core idea. Components called producers create events, like order created, and then send them out. Other components, called consumers, listen for these specific events and do whatever needs to be done as a result. A central hub, often an event bus or broker, makes sure everything gets routed correctly. This design is fantastic because it keeps things separated, which means your system can easily grow and handle more traffic. It's also more resilient, since if one part fails, the rest of the system keeps running. Let's dive into containerization. Specifically, we're looking at Docker. Containerization is all about packaging your applications and their dependencies together so they run consistently no matter where you move them. It's like creating a little portable box for your software. Docker is the most popular tool for this, using images which are templates and containers which are the running instances of those images. A Docker file guides how to build these images. Essentially, it allows you to deploy applications easily across different environments, ensuring they behave exactly as expected. Okay, let's talk about keeping all those containers running smoothly. Container orchestration is basically the system that manages groups of containers, making sure they're deployed correctly, scaled up or down as needed, and generally just staying happy. We have a few big players in this space: Kubernetes, which is super popular and flexible; Amazon ECS, if you're heavily invested in AWS; Azure Kubernetes Service for those using Microsoft Azure; and Google Kubernetes Engine, powered by Google's awesome infrastructure. Each one offers slightly different features and integration with their respective cloud platforms, so understanding these choices is a big part of being a successful cloud engineer. Let's talk about infrastructure as code. Think of it like building with blueprints instead of laying bricks one by one. Instead of manually configuring servers and networks, we define what our ideal infrastructure should look like in code, usually using things like YAML or JSON files. These files tell a tool like Terraform exactly how to build and manage everything. It's all about describing the desired state, making sure things are consistent every time, and automating the whole process. This leads to faster deployment, fewer mistakes, and easier collaboration among your team. Pretty awesome, right? Okay, so let's talk about Terraform. It's all about treating your cloud infrastructure like regular software. Instead of manually clicking through the web console, you write code, specifically a configuration file that tells Terraform exactly what you want to build and manage. This is called being declarative, which means you describe what you want the end result to be, not how to get there. It then figures out all the steps needed to achieve it. Terraform uses providers to connect to different cloud platforms like AWS or Azure. Think of resources as individual building blocks: a virtual machine, a database, or even a network that you define in your code. And finally, modules are like reusable blueprints for your infrastructure, making things easier to manage and share. Okay, let's talk about CloudFormation templates. They're absolutely crucial for any serious cloud engineer. Think of them as blueprints for your entire AWS environment. You write these templates using either YAML or JSON, which is a human-readable way to describe exactly what infrastructure you want. Then you upload this template to CloudFormation, and it handles the whole process, creating the servers, setting up databases, building out your network, and importantly, it keeps track of everything, so changes are consistent and easy to manage. Okay, So today we're diving into how Pulumi and ARM templates work together to really simplify cloud infrastructure management. ARM templates are essentially blueprints. They tell Azure exactly what resources you want and their configurations. Think of them as a recipe for your cloud environment. Now, Pulumi is this awesome tool that lets you write those recipes using languages like Python or TypeScript. It takes your code and automatically transforms it into an ARM template, making the whole process much more flexible and powerful than traditional methods. Let's talk about configuration management. It's basically the engine that keeps your cloud infrastructure running smoothly and consistently. Think of tools like Ansible, Chef, and Puppet as automated helpers that handle everything from installing software to updating security patches. Ansible is super easy to pick up, great for smaller teams. Chef offers a lot more control if you have a bigger setup, and Puppet takes a slightly different approach with its declarative style. Ultimately, these tools ensure your cloud environment stays predictable and reliable, which is absolutely crucial for any serious operation. Okay, so let's tackle cloud costs. They can really add up if you're not careful. First thing is to make sure you aren't paying for more computing power than you need. It's easy to accidentally over-provision your instances, so use the tools provided by your cloud provider to check how much each one is actually being used. Next, consider reserved instances or savings plans. These are great deals if you have predictable workloads. And don't forget about auto-scaling. This allows your resources to automatically adjust based on demand, ensuring you only pay when you're actively using them. Finally, think about how you're storing your data. Cheaper storage tiers exist for less frequently accessed files. Okay, let's talk about how cloud instances cost you money. There are a few main ways to pay, and it's important to understand them. First up is on-demand instances. This is the simplest model, where you just pay for what you use, kind of like a utility bill. It's super flexible, but can be the most expensive over time if you're running things consistently. Next are reserved instances. These let you lock in a discount by committing to using a particular instance type for 1 or 3 years. This is fantastic if your needs are pretty predictable, and it helps lower your overall costs. Finally, we have spot instances. These are like bidding on spare compute power from Amazon. You get huge discounts, but they can be interrupted with little warning. They are perfect for workloads that can handle being stopped and restarted without a problem. Okay, so let's talk about keeping tabs on those cloud costs. It's really important as a cloud engineer to understand where your money is going. Luckily, the major cloud providers offer some fantastic tools to help with that. AWS Cost Explorer lets you see how much you're spending by service or even specific instance types. Google Cloud has detailed billing reports that break down exactly what you're using. Azure uses cost management and Showback to give visibility across teams. And there are third-party options like Cloud Health that can actually suggest ways to save money. The key is to go beyond just seeing the numbers, really dig into the data to find opportunities for optimization. Let's talk about keeping your cloud data safe. First off, we need to make sure everyone only has access to what they absolutely need. That's the principle of least privilege. Think of it like giving keys out. Don't hand out the master key. Also, encrypting your data both when it's stored and when you're moving it around is vital. And don't forget about your network. Use things like VPC to create secure zones for your applications. Regularly checking for weaknesses, vulnerability management, and keeping everything updated is another big step. Finally, constant monitoring, logging everything, and watching for anything unusual will help you spot problems before they become serious. Let's talk about keeping your cloud applications safe, specifically how we manage secrets. Think of these services as secure vaults for sensitive information like passwords and API keys. We've got 3 main players: AWS Secrets Manager in the Amazon Web Services world, Azure Key Vault over at Microsoft, and GCP Secret Manager within Google Cloud. They all offer a way to store your secrets securely and control exactly who can access them. Each one has its own way of handling permissions, so you can make sure only authorized users or services are ever touching those keys. Okay, let's talk about compliance and governance when you're working with the cloud. It's a really important area. because clouds can be, well, a little bit wild. You've got all sorts of regulations like GDPR for data privacy or HIPAA if you're dealing with health information. Then there are things like where your data actually is stored that matters legally too, particularly when it comes to data residency and sovereignty. We also need to think carefully about who has access to what. The principle of least privilege is key here. And finally, constant monitoring and auditing are a must. You need to be able to see what's happening and quickly respond to anything that looks suspicious. Okay, so let's talk about the shared responsibility model. Think of it like a partnership. You and your cloud provider both have roles to play in keeping things secure. The cloud provider takes care of the foundational stuff, like the physical security of their data centers and the underlying infrastructure. But you are responsible for everything running on top of that, securing your operating systems, your applications, your data, and how people access it all. It's really important to understand where those lines blur so you can be proactive about protecting what matters most. Okay, let's talk about moving applications to the cloud. It's not just a simple copy and paste. We have 5 different strategies we can use, often referred to as the 5 R's. The first is rehost. Basically, you lift your application up and shift it directly to the cloud without making any major changes. It's the quickest option, but it might not fully utilize all of the benefits that the cloud has to offer. Next up is refactor. This means tweaking your existing code to improve its performance and scalability in the cloud environment. Then there's rearchitect, which involves a significant redesign, often breaking down monolithic applications into smaller, more manageable microservices. Rebuild is about starting fresh with a completely new application designed from the ground up for the cloud. And finally, replace means swapping out your current solution entirely for a different one, like moving to a software as a service product. Let's talk about how we automate our deployments in the cloud. CI/CD is all about streamlining the process of getting your code from development to production. We've got some really powerful tools out there that can handle this for us, like AWS Code Pipeline, a fully managed service that takes care of everything from source control all the way through deployment. Then you have Azure DevOps, which offers a complete set of development tools including pipelines. And finally, Google Cloud Build is another great option if you are already using Google Cloud. Okay, let's talk about source control, specifically how it's essential for cloud engineers. Think of it as your project safety net. We use platforms like GitHub, GitLab, and Bitbucket to manage our code effectively. GitHub is super popular due to its huge community and tons of integrations. GitLab shines when you want a complete DevOps workflow with built-in CI/CD pipelines. And Bitbucket works particularly well if you're already using Atlassian tools like Jira. It's all about repositories, branches for working on new features independently, commits to track those changes, and pull requests, which are basically a way to review code before it gets merged into the main project. Okay, let's talk about automating how we build and deploy our cloud applications. Think of it like an assembly line for software, constantly building, testing, and pushing out new versions. We use continuous integration to automatically compile and test code wherever someone makes a change. Then, using continuous delivery or deployment, we automatically push those changes through various environments from staging to production. And we use infrastructure as code to manage all of our cloud infrastructure, with code 2 making sure everything is consistent and repeatable. Tools like Kubernetes and Jenkins help us orchestrate the whole thing, ensuring smooth, automated releases. Okay, let's talk about designing applications for the cloud in a modern way. We're talking about cloud native. Instead of building big, complex systems that are hard to change, we break things down into smaller, independent pieces called microservices. Think of it like Lego bricks. Each brick does one specific thing really well. We package these services up into containers, mainly using Docker, which ensures they run consistently everywhere. Then, Kubernetes steps in as the traffic controller for our containers, automatically making sure they're running and scaling as needed. It's all about speed, resilience, and keeping things automated with DevOps practices like CI/CD. Don't forget observability. You need to be able to see what's going on inside your system. Let's talk about microservices in the cloud. They're a really powerful way to build scalable and resilient applications. Think of it like taking one giant software program and breaking it down into smaller, more manageable pieces or services that each do their own specific job. Cloud platforms make this incredibly easy because you can scale these individual services up or down as needed, and if one service has a problem, the rest of your application keeps running smoothly. Plus, you have the flexibility to use different technologies for each service, which is a huge advantage. Let's talk about API gateways. They're essentially the main entry point for all requests hitting your cloud applications. Imagine them as a security guard and traffic controller. They handle everything from routing those requests to the right service, making sure only authorized users get through, and even slowing down any potential attackers. Popular cloud providers like AWS, Azure, and Google Cloud all offer their own versions of API gateways. They really help simplify how applications interact with your backend systems. Okay, let's talk about securing the edges and perimeters of your cloud environment. It's like building a really strong wall around everything, preventing bad guys from getting in. We use things like cloud-native firewalls to act as gatekeepers, web application firewalls to protect web apps, and intrusion detection/prevention systems to spot suspicious activity. And increasingly, we're seeing zero trust network access being used, which is a really important shift toward verifying every user and device before they can access anything. Remember, the key is always least privilege, only giving people what they absolutely need. Let's talk about securing your cloud connections. A VPN, or virtual private network, is like building a secret tunnel for all the data traveling between your computer and the cloud. Why do we need this? Well, it's all about security, protecting sensitive information from potential threats and ensuring you can access your resources safely, even when you're not in the office. Most major cloud providers have their own built-in VPN options or work well with services like OpenVPN. You'll need to set up a gateway within your cloud environment, create client configurations that your devices use, and install the necessary software. And don't forget to keep everything updated for optimal security. Let's talk about how to securely connect your data center to the cloud. We've got three main options: Direct Connect, ExpressRoute, and Dedicated Interconnect. Think of them as private highways built just for you. Direct Connect is a dedicated connection managed by the cloud provider itself. It gives you consistent performance but can be a bit less flexible. ExpressRoute is Microsoft's offering, using secure VPN tunnels over your existing network. And then there's Dedicated Interconnect, where a third-party provider like Equinix physically connects you to the cloud data center for maximum bandwidth. The best choice really depends on what you need and how much you're willing to spend. Okay, let's talk about caching. It's all about speeding things up for your applications. We use cloud caching services to store frequently accessed data closer to the user, drastically reducing response times and improving overall performance. There are a few major players out there: Amazon Elasticache, which offers both Redis and Memcached. Redis, available from various providers like AWS, Google Cloud, and Azure. It's super versatile for things like session management and real-time analytics. And then Google Cloud's own offering, Cloud Memory Store, also based on Redis. When picking a service, think about your budget, how easily it connects to the rest of your cloud setup, and what type of data you need to store. Let's talk about message queues. They are like invisible post offices for your applications. They help different parts of a system communicate without being directly linked, which makes everything more reliable and able to handle lots of activity. We'll look at three big players: Amazon SQS, Azure Service Bus, and Google Cloud Pub/Sub. Each has its strengths, but they all share the same core purpose: keeping your applications running smoothly by handling messages efficiently. Okay, let's talk about managed Kubernetes services. Think of Kubernetes as a really powerful way to manage containerized applications, but it can be tricky to set up and maintain on your own. That's where EKS, AKS, and GKE come in. These are managed services from AWS, Azure, and Google respectively. They basically handle all the complicated bits like scaling, patching, and upgrades for you, so you can concentrate on building awesome applications. Each provider X, AX, and GKE offers a similar core functionality, but with their own specific features and integrations within their respective cloud ecosystems. It's great because it helps reduce operational overhead and makes managing your containers much easier. Okay, let's talk about Cloud Identity Federation. It's a really important concept for cloud engineers. Basically, it's all about making sure your users can access everything in the cloud without needing tons of different usernames and passwords. Think of it like this. You have one main identity source, maybe something like Active Directory or Azure AD, and that acts as the central hub for who everyone is. Then, you build trust between that central system and all the individual cloud services OS, Google Cloud, Microsoft Azure, whatever they are. Once those trusts are in place, users can log into one place and automatically access their resources across multiple environments, making things much simpler and more secure. Okay, let's talk about how we store files in the cloud. Instead of managing physical disks, many cloud services offer managed file systems. Think of them as central hubs for storing data accessible to your applications. We have a few popular options. Amazon EFS, its AWS fully managed NFS service and scales automatically. Then there's Azure Files, which provides SMB file shares in the Microsoft Cloud, perfect if you need traditional Windows file sharing. Finally, we have Google File Store, a high-performance NFS solution on Google Cloud. Each has its own strengths. Understanding these differences will help you choose the right tool for your specific project. Let's talk about securing your cloud environment, specifically firewalls. As we move more and more into the cloud, traditional perimeter defenses don't always cut it. That's where cloud firewalls come in. AWS Network Firewall is a fully managed option that inspects traffic at Layer 3 and Layer 7 to protect your VPC. It's all about rule-based filtering and integrating with threat intelligence. Then there's Azure Firewall, another fantastic choice, also fully managed and offering similar capabilities. It specializes in securing multi-cloud environments really well. We've put together a quick comparison table here to highlight the key differences between them. Ultimately, choosing the best firewall depends on your unique setup and what you need to protect. Okay, let's talk about the command line, specifically how it's super important for cloud engineers. We're diving into Cloud CLI like AWS CLI, Azure CLI, and gCloud. Think of them as your direct connection to each cloud provider. Instead of just clicking around in a web console, you can actually tell the cloud what to do using commands. Each one: AWS CLI for Amazon Web Services, Azure CLI for Microsoft's Azure, and gCloud for Google Cloud Platform lets you manage things like virtual machines, storage, and security roles directly from your terminal. They're fantastic for automating tasks and really understanding how everything is set up. Let's talk about how SDK and API are your key to unlocking the power of the cloud. Think of an SDK as a toolbox packed with everything you need to build apps specifically for a particular cloud provider, like AWS, Azure, or Google Cloud. These SDK provide ready-made code libraries and documentation that make working with those services much easier. API are even more fundamental. They're essentially instructions on how different software systems can talk to each other. In the cloud world, API let you send requests to services like storage or databases and get results back automatically, all without needing to write complicated code from scratch. We'll look at some of the most popular SDK, AWS, Azure, and Google Cloud, and touch on important concepts like REST and gRPC API. Mastering these tools will really set you up for success as a cloud engineer. Okay, so let's talk about building serverless apps. We have a few fantastic frameworks that really simplify the process. First up, a serverless framework. It's super popular because it works with lots of different cloud providers like AWS, Azure, and Google Cloud. Next, we have AWS SAM, which is specifically designed for building applications on Amazon Web Services. And finally, there's Chalice, a framework that's particularly great if you're using Python. It's known for being really quick to get started with. Let's talk about how we collect logs in the cloud. It's super important to understand what's happening inside your applications and infrastructure. right? Cloud-native logging means collecting logs directly from your services, no more dumping them into a single location. We have three major players. Amazon CloudWatch Logs integrates really well with other AWS stuff. Google Cloud Logging, formerly Stackdriver, is powerful for the whole GCP ecosystem, and Azure Log Analytics is part of Azure Monitor, using KQL to analyze everything. Think about how much data you're generating and make sure your logging solution can scale as things grow. And also consider costs. Optimizing retention policies will help keep those bills down. Okay, let's talk about how cloud engineers can really take control of their environments. We often don't get everything we need out of standard monitoring tools, so the first step is to create custom metrics data points specific to what matters most for your applications and services. This involves adding code to your apps to report those metrics, then collecting that data with tools like Prometheus or CloudWatch. You'll often want to aggregate and transform the raw data into something easier to understand, like calculating averages or percentiles. It's all about getting a really focused view of what's going on. Okay, let's talk about hybrid and multi-cloud strategies. They're really shaping how companies approach the cloud now. Essentially, a hybrid cloud means you're combining your existing data center with public clouds like AWS or Azure. Think of it as having the best of both worlds. And multi-cloud takes that a step further. It's using services from multiple public cloud providers at once. This gives you serious advantages like greater resilience, so if one provider goes down, your business keeps running. It also lets you pick the most cost-effective solution for each specific task and helps you avoid getting locked into a single vendor. Okay, so let's talk about connecting your different networks in the cloud. We have two main concepts here: cloud peering and VPC peering. Think of cloud peering like building a direct tunnel between two completely separate clouds. It's perfect if you need to share resources or data between them, like for disaster recovery or a hybrid setup. VPC peering is more about connecting networks inside the same cloud provider. It's generally free and really useful for organizing your applications into isolated environments or splitting up large workloads. Okay, let's talk about AWS Database Migration Service, or DMS for short. Think of it as your friendly helper when moving databases to the cloud. It's a fully managed service, meaning you don't have to worry about setting up and managing complex infrastructure. DMS helps you migrate databases like Oracle, MySQL, or PostgreSQL to Amazon Aurora or other targets. The process generally involves an initial assessment to spot any potential problems, schema conversion if needed for different database types, continuous data replication so minimal downtime during the switchover, and finally, a cutover when your apps are ready to use the new location. It's designed to make the whole thing much smoother. Okay, let's talk about cloud marketplaces. Think of them as one-stop shops for all the services you can find in major cloud platforms like AWS, Azure, and Google Cloud. They really simplify things by making it easier to discover and deploy solutions from different vendors. You don't have to spend ages figuring out which service is best or how to set up each piece. Marketplaces offer pre-built templates and automation, so you can get things running much faster. Plus, they help you compare pricing across providers, so you can make the most cost-effective choices for your needs. Okay, let's talk about immutable infrastructure. It's a really powerful concept in cloud engineering. Basically, we stop thinking about servers as things you constantly tweak and update. Instead, we treat them like disposable units. When you need to make a change, you build a completely new server from scratch using your code, rather than modifying the old one directly. This simplifies everything. It cuts down on complexity, makes rollbacks super easy if something goes wrong, and generally boosts reliability because there are fewer manual steps involved. Think of it like building with Legos. Instead of constantly gluing pieces together, you start fresh each time. Okay, let's talk about application load balancing and how path-based routing fits in. Basically, an ALB is like a smart traffic cop for your applications. It makes sure that incoming requests get distributed evenly across multiple servers, which means no single server gets overwhelmed, improving availability and speed. Now, path-based routing takes this a step further. Instead of just distributing based on general rules, it looks at asterisk, where asterisk the request is going within your application, specifically the URL path. So if someone visits /images, the ALB sends that traffic to the server best suited for handling image requests, and if they go to /API/phone, it directs them to the API server. It's a really powerful way to optimize performance by sending each type of request to its dedicated handler. Okay, let's talk about keeping your cloud apps secure, specifically SSL/TLS certificates. In a cloud, managing these can seem a bit complex, but there are some really great strategies you can use. First off, many cloud providers offer managed certificate services like AWS Certificate Manager or Azure App Service Certificates. These make generating and renewing certificates way easier than doing it all yourself. You'll also want to consider centralized management platforms tools that let you handle certificates from one place. And the big key here is automation. Using IC allows you to build in automatic certificate creation, deployment, and renewal, which significantly reduces errors and keeps things consistent. Finally, don't forget about lifecycle management, setting up notifications for when certificates are nearing expiration so you can proactively renew them before they expire, preventing any downtime. Okay, let's talk about automating how we deploy things in the cloud. It's a huge deal for making sure everything runs smoothly and consistently across environments. We'll cover some popular languages like Bash, Python, and PowerShell. Each has its strengths. And don't forget about tools like Ansible, Terraform, and AWS CloudFormation. They really simplify the process of defining what you want your cloud infrastructure to look like. Let's talk about how we can make cloud security smarter with Cloud Policy as Code. Basically, instead of setting rules manually, which is prone to errors and hard to scale, we define those rules in code. We use tools like Open Policy Agent or OPA, along with Sentinel, a handy Kubernetes-focused option, to create our policies. It's all about treating security configurations just like any other infrastructure component, using infrastructure as code, so it's consistent and easily tracked across your whole cloud environment. This automation and standardization brings huge benefits: faster response times when things change, better auditing, and ultimately, a much more secure cloud. Okay, let's talk about RBAC, role-based access control, in the world of cloud computing. It's a really important concept for keeping your data safe. Basically, it means you don't give everyone full access to everything. Instead, you create roles based on job functions like developer, administrator, or even just read-only. Then, you assign specific permissions, things like the ability to upload files, modify settings, or just view information to each of those roles. Finally, you assign users to these roles, giving them only the access they absolutely need to perform their duties. It's all about minimizing risk and making sure things stay secure. A good RBAC strategy also helps with compliance and keeps your cloud environment tightly controlled. Let's talk about web application firewalls, often called WAF. Think of them as the extra layer of security protecting your web apps from bad actors. They sit in front of your applications, examining all incoming traffic and blocking anything suspicious like attempts to hack or overwhelm your system. We'll look at three major providers: OSWAF, Azure WAF, and Google Cloud's Cloud Armor. Each integrates with their respective cloud platforms, OS, Azure, and Google Cloud respectively, providing robust protection for your web applications. Let's talk about service meshes. These are like invisible helpers for your cloud applications, making them more reliable, secure, and easier to manage. There are a few major players. This tier is really popular with Kubernetes, especially if you need lots of advanced features. Linkerd is simpler and faster, great for smaller projects. And then there's Console Connect, which works seamlessly with HashiCorp's console tool for service discovery. Essentially, they both use proxies to sit in front of your services, making sure everything talks properly and securely. Okay, let's talk about protecting our data in the cloud. As cloud engineers, we need robust backup and archive solutions. Services like AWS Backup and Azure Backup can automatically back up your virtual machines and databases either regularly or when you need it. For long-term storage of things that aren't accessed often, object storage archiving is a fantastic option, significantly cheaper than regular storage. And don't forget hybrid backup strategies which combine on-premise protection with the benefits of the cloud. When choosing a solution, think about how quickly you need to recover data RTO, how much loss you can tolerate RPO, and make sure it aligns with any compliance regulations you have. Okay, let's talk about log analysis. It's absolutely crucial for any cloud engineer. Think of logs as a detailed record of everything happening in your systems. We use tools like the ELK Stack, Elasticsearch, Logstash, and Kibana to collect, process, and visualize these logs. Elasticsearch is where all the data lives and gets indexed. Logstash brings in the logs from different places and cleans them up, and Kibana lets you actually see what's going on with charts and graphs. Grafana is another fantastic tool that can be used to build really powerful dashboards alongside your logs. And finally, don't forget about cloud-native solutions. Platforms like AWS CloudWatch or Azure Monitor provide built-in ways to monitor your infrastructure directly. Let's talk about cloud cost forecasting. It's a really crucial step for any cloud engineer. It's not enough to just pay your bills as they come in. You need to plan your spending. Forecasting helps you build realistic budgets, spot wasteful resources that aren't being used, and ultimately take control of your costs. There are a few ways to do this, starting with looking at what you've spent previously using tools like AWS Cost Explorer or Azure's cost management dashboards. Then look for trends. Are your costs increasing, decreasing? And for more complex environments, predictive modeling can be really powerful. Let's talk about something really important for any cloud engineer: service level agreements, or SLA. Think of them as promises from your cloud provider about how reliable their services are. They are basically contracts that outline things like uptime, how much time a service is actually available, and response times. There are different types of guarantees too, from uptime percentages to data durability. And remember, SLA aren't just nice to have, they're often legally binding, so understanding them deeply is key for keeping your systems running smoothly and protecting your users. Okay, let's talk about building really efficient software delivery with cloud-native DevOps. The key is moving away from separate teams and tools working in isolation. We're talking about creating interconnected toolchains that automate everything from code changes all the way to deployment and monitoring. Think of it like a well-oiled machine. You have your CI/CD platform handling continuous integration and continuous delivery. Then configuration management tools ensure consistency across environments. Container orchestration platforms like Kubernetes handle scaling and managing those microservices. Service meshes help manage communication between services. And finally, monitoring and logging tools keep an eye on everything to make sure it's running smoothly. Each component plays a vital role in this automated process. Okay, let's talk about keeping an eye on those containerized applications. It's super important to know what's happening inside them. We want to track things like how much CPU and memory each container is using, its network activity, and even how full its disk space is. Then, we need a way to collect all the logs from every service. It's like having a detective looking for clues. And don't forget about application performance monitoring. These tools help us see exactly how quickly requests are being processed and where any issues might be popping up. Finally, health checks in our orchestration platforms make sure that if something goes wrong with a container, it gets automatically restarted. Setting up alerts based on those metrics is key. We want to know before an issue impacts users. Okay, let's talk about compliance. As a cloud engineer, you need to make sure your cloud environment isn't just secure, but also meets all the necessary regulations and standards. To help with that, there are some fantastic tools out there. We've got cloud security posture management systems like AWS Security Hub and Azure Security Center. These automatically scan for misconfigurations and vulnerabilities. Then you have SIEM solutions to collect and analyze security events. And a really cool trend is compliance as code, which allows you to automate compliance checks using things like Terraform, making sure everything's configured correctly from the start. Okay, let's talk about bringing your content closer to where it's needed most. We're diving into edge computing and how content delivery networks play a crucial role. Edge computing essentially means processing data right at the source. Think devices like smartphones or IoT sensors instead of sending everything back to a central cloud server. This dramatically cuts down on latency, making things feel faster and more responsive for your users. Then we have CDN. These are networks of servers strategically placed around the world. When someone requests something from your website or app, the CDN automatically directs them to the closest server, ensuring they get it super quickly. And optimizing a CDN involves techniques like caching frequently accessed content and compressing files so they download even faster, really all about delivering a seamless experience for your audience. Let's talk about how API management fits into cloud-native systems. Think of it as the control panel for your microservices. Instead of one giant API, we're building smaller, independent services that each have their own interface. This allows us to manage everything in a more flexible and scalable way. We use things like dynamic routing to send requests to the right service automatically and policy enforcement to keep our APIs secure and performant, all managed from a central point. Let's talk about connecting your existing data centers with the cloud. Many companies don't want to completely rip and replace everything. They need a way to work together. We often see organizations using VPN, which are like secure tunnels for data transfer. But for really demanding applications, a dedicated connection like Direct Connect or ExpressRoute is much faster and more reliable. And it's not just about the network. You also need consistent security policies. Everyone needs to be on the same page. Think of it as building a bridge between your old world and the new one. Okay, let's talk about securing your cloud applications, specifically how we do it in a modern way. We're moving away from just bolting on security at the end of a project. Instead, shift left security, which means building security directly into the development process itself. Think DevSecOps. A core concept is zero trust, meaning we assume no one is inherently trusted and always verify access requests. We also need to focus on granting users and services only the minimum necessary permissions, least privilege. Finally, using immutable infrastructure, deploying changes as completely new versions helps significantly reduce risk. Okay team, let's dive into how we can make security a core part of our CI/CD workflow. It's no longer enough to just check for vulnerabilities at the end. We need to find them before they become problems. We'll be looking at several different types of scanning, things like SAST, which checks your code itself, DAS, which tests a running application, and even scanning our infrastructure configuration templates. Container image scanning is also hugely important, as is monitoring for issues while applications are actually running. The goal? To build security right into how we deploy, making our cloud environment much more robust. Okay, let's talk about disaster recovery testing. It's a really crucial part of being a cloud engineer. Think of it like this: you've built your backup system, great. But are you sure it works? We need to actively test it, verifying backups are actually restorable, practicing switching to a failover environment if something goes wrong, and measuring how long things take to come back online. There's different types of tests, like checking backups and simulating outages. And it's not enough to just do this once. You should regularly review your plan and update it as your systems evolve. Okay, so let's talk about keeping things running smoothly in the cloud. Change management is absolutely essential. It prevents chaos and ensures stability. The first step is to plan your changes meticulously. Figure out exactly why you're making the change, what you're going to do, how you'll do it, and when it will happen. A good framework like ITIL can really help with this. Next up, we need to assess the risks. What could go wrong? Let's identify potential problems and have plans in place to fix them if they arise. Communication is hugely important to keep everyone involved informed throughout the process. And finally, don't skip testing. Thoroughly test your changes in a staging environment before deploying anything to production. Okay, let's talk about zero trust security in the cloud. It's a fundamental shift from how we used to think about protecting our data. Instead of relying on a traditional castle and moat approach, basically securing everything outside your network, Zero Trust assumes that threats are already inside. It's all about continuously verifying everyone and everything trying to access resources. We focus on granting only the absolute minimum level of access needed, and then constantly checking if that permission is still valid. Think of it like this: even if someone gets past the firewall, they can't do much damage because their access is tightly controlled. Technologies like MFA, microsegmentation, which divides your network into smaller, isolated zones, and robust IAM systems are all crucial components of a Zero Trust strategy. Thank you for watching.